warm welcome. So let me just give a brief introduction about the organization and welcome you all for this conference. So I myself, Dr. Ravi Kumar. Time zone. Hope I am audible. Hope I am audible.
Yes, you are audible.
Let me just. Yeah, am I audible now?
Yes.
Okay. So welcome to the International Conference and Members Meeting organized by Research World in association with many organizations like RWYS, WR, and WRS. On behalf of this entire organizing committee, I'm Dr. Ravi Kumar, organizing conference chair for the day. I would like to welcome you all for this virtual conference. So talking about this Research World, it is the world's largest non-profitable professional organization meant for research, development, and promotion in the field of science, engineering, technology, economics, and social science, medical health. The Research World is a paramount body which has brought technical revolution and sustainable development of science, engineering, technology, management, economics, social sciences, medical, and health sciences. So with this, we will quickly go ahead and start with the conference. Now, I would like to welcome today's keynote speaker also for the day. The keynote speaker is Dr. Chuan Lee. Ma'am, Chuan Lee, topic dietary bioactive compounds for neuropathic pain, current preclinical findings and future direction. So welcome them. I welcome you as a keynote topic for the day and enlighten us with this your immense research to the fraternity out here, and we will quickly go ahead and start with it. Before that, let me just also brief about myself. I'm Dr. Ravi Kumar. I am basically from mechanical engineering background. Along with that, I have various and also like my area of specialization is quality management and also additive manufacturing, 3D printing, and data science. And these are some of my areas of interest where I usually work on. And it's really a great opportunity where I've got to interact with the foreign, many professors across the globe. And I also work in a university here in India, and then we are ready for research collaborations, joint publications, students and university faculty exchanges, if any university would love to. So all these things we can discuss also. But before that, let us get back quickly to the conference, and I welcome you all for this conference. I welcome and hand over today's keynote session and enlighten us, Chuan Lee Shen.
Hello, everyone. I don't know, good afternoon or good morning. I'm Leslie from Texas Tech Health and Center, Lubbock, USA. So my topic is I want to share some concept about neuropathic pain, how the biotic compound can help. So neuropathic pain is a damage in the nerve fibers and sending from the wrong signals from the bottom peripheral nerves to the CNS. Then it's very difficult to treat. So available treatment are really limited. So we want to find some way to help. So from metabolic biological concept is neuropathic pain induce a lot of oxidative stress, and that will induce a lot of inflammation and cause the mitochondrial apoptosis, then make a DNA oxidation. And your body has some antioxidant defense, but it will decrease because of neuropathic pain. And your structural damage will have changed, and that will cause all the biological part. A new concept is there's the leaky gut concept. That means the neuropathic pain, the guts have the leaky, increase the permeability. So the products will diffuse out and go to the circulation system and will impact it. So that's the gut microbiome, how involved in the neuropathic pain. So today I want to focus on ginger, because ginger is a very natural product and you can have a daily life. So ginger depends on the stage of the either is the fresh ginger, the major compound gingerols, or you heat up, cooking, or dehydrate, then product called the sugars. So today we want to mention about, I published paper using 2 different ingredients of ginger to look at neuropathic pain. So we use the model, it's common model neuropathic pain, and different ingredient neuropathic pain, the ginger compound to do that. So we assess the pain sensitivity, and we look at the mitochondria, how they work, and the gut microbiota composition, and the fecal metabolites. So in this study, we found out that both either gingerol or sugar, they all reduce the pain. This is the mechanical hypersensitivity models. So no pains, animal will stay longer for this the stimulus. So the reading is higher after pain, then goes to really sensitive, and you withdraw, then withdrawal threshold is decreased. So we found that both the ginger ingredients reduce the pain. And this look at the gut microbiome composition. You see the first one, the second one is a model, the third one plus the ginger, 2 different kind of gingers ingredients. So you can see the model, compared to models, pain model, both ingredients have very similar patterns here. So that's how the gut microbiome composition has been modified by the ginger. So we look at they pretty much has the very similar composition. They found out they have the body compounds that can induce oxidative stress and reflux. So this look at how the composition of the fecal metabolites we collected to run the metabolites, and we see if they have different directions, some of them is significantly different from each other. So for the GEG or SEG, they are significantly different from the SNL, which is model in gray color. So what we found out in the metabolites is the ginger can have the ingredients, metabolites has anti-inflammatory effects, and they all show to support the concept, the ginger reduced neuropathic pain. So that question is how the ginger will affect the leaky gut. So we have a similar model, use the ginger to treat the animals. What we found that animal also reduce the pain by ginger. And this is the different ways to look at the pain scale. They all reduce the pain. Then we measure the sugar concentration in the urine. The higher number ratio means the more leaky gut. So compared to model, the ginger given to animal, they have significantly reduced the ratio of the lactulose to menopause. That means reduced leaky gut. So we look at the amygdala and the colon. We want to connect to the GI and the brain. So we found out the colon, amygdala, they have some degree of the reduction of the expression for TN alpha and NF kappa in this colon, the amygdala, suggesting the ginger reduced the neuropathic pain through the reduced inflammatory action. So we want to see how to further down, how to do. Then we compare to even dose response, 200 and 600 dosage of this one. It's kind of 3 times dose. We don't see a significant difference in animal response to the mechanical hypersensitivity. And we also see some dose response for the richness of the gut microbiota. And these 2 figures is the compared to model. The dosage at 200 milligram per kilogram ginger compared to 600, they follow very similar patterns, but have some degree probably the dose response. And we found out the affected microbiome is really related to the reduced potential per inflammatory taxa. So we go further to look at what kind of new information affect the gene here. So what we found out compared to model, both the ginger 200, 600, they have 3 important gene has been affected by ginger treatment. And these 3 genes is the FOS and the GAT45G and the HEC2. So we confirm with the RT-PCR. So that shows that the ginger supplementation reversed these neuropathic pain-induced changes in this molecular signal check. So this is the summary of how we found out ginger. They can modify the gut microbiota composition and the fecal metabolites, and they will affect the nerve system and reduce they found out to reduce the inflammatory cytokine production, and they will reduce the pain hypersensitivity. The future direction will want to translate from the animals to result to human study with the neuropathic pain such as sciatic pain. And I thank you for this the sponsor to sponsor my research, and this is my team. Thank you.
I'm from Turkey and I'm a historian, and today I will tell you about the works of Byzantine and Seljuk women. Thank you. First, the effectiveness of women in the Seljuks in the management, economics, and making political decisions is well-known fact. In addition, although there are some traditional themes that restrict them from being able to decamp comfortably among the people, it's clear from the foundation works they have established that the Sultan's wives have unlimited say over their wealth. In the Seljuks of Turkey, the Sultanate foundations can be seen as an expression of the religious, social, political, and economic policies of the Sultan or the viziers and statesmen subordinate to him. The foundations of the foundation work established by the Sultan's wives and daughters are also very limited, and monographic works containing their biographics and foundations are almost non-extant. Therefore, it's an important requirement to question how the women of the Seljuk dynasty used the Vakf system as a means of representing themselves and changing visibility in society. In addition, the lack of wills, court records, or similar archival materials to support these foundations also make it difficult to establish the representation and effectiveness of these women in society other than foundation works. In the Byzantine world, one of the most effective ways for people of aristocratic origin or countries to show their generosity and importance to the society in which they live to lead the creation of works of art that will win the public's appreciation. This understanding acquired new meanings with Christianity. Works of art were considered one of the most effective ways to express the strong faith of the Byzantine in God, feelings of graduated or credited. In the early centuries of the Byzantine civilization, the nature of the works that were realized with the patronage or financial support of women varies according to the wealth of the donor and his status in society. The nature of these donations, which are usually realized under the influence of the Christian faith, can reach up to a monumental size church built by a rich, influential, and imperial family prince such as Anicia Juliana. In this study, the reasons why women patrons of art gave monetary support to a work of art during the early Byzantine and Turkish Seljuks will be examined, and contributions of banality to the social and economic status of women will be emphasized. And Byzantine female patrons. Constantine I became a role model in the application of piety and philanthropy as virtues of the imperial woman. Helena, the first Christian empress, gained a great reputation by finding the real cross on which Jesus was crucified in Jerusalem, where she wanted to become a pilgrim in 3026. She also built a church of the birth of Jesus in Bethlehem and church of the Assumption of Jesus on the Mount of Olives. and gave the first examples of the female patronage with this new religious identity. However, the extent of Helena's patronage was increasingly exaggerated, and later empresses who followed in her footsteps were praised as the new Helena, with over 30 churches being said to have been built in the Holy Land. One of the empresses who showed her piety by building churches was Aelia, whom we know as the wife of the Eastern Emperor Arcadius. It's Eudokia. Eudokia, who took the title of Augusta in 40 BC, was the wife of Theodosius I and mother of her husband, Arcadius. During her lifetime as Aelia, she adheres to the famous virtues of Flacia, the Gaza Cathedral, which was built between 42 and 402-407, but has not survived, is one of the projects realized with its financial support. These examples will be increased. And so, as Selçuk women patrons, there are 3 female foundation fathers from the Turkish Selçuk period whose foundation certificates have survived to the present day. One of them is Raziye Devlet Hatun, Gıyasettin Keyhüsrev's daughter is Fatma Hatun, and the other one is Mahberi Hatun, wife of Alaaddin Keykubat. Apart from that, it's possible to obtain information about the surviving works of women from the dynasty family who established foundations, from the inscriptions of the buildings and the archive records of the Ottoman period. In Konya and other Selçuk cities, not only women from the dynastic family, but also the daughters and wives of statesmen, freed slaves and people with sufficient financial means had foundations built or made various donations to foundations established by their support. Melik's daughter, Efray Hatun, who had a madrasa built in Kırşehir in 1207, and Fahrun-Nisa Nizam Hatun, one of the Mevlana's scribes, are among them. Kütahya Yoncalı hot spring, one of the oldest thermal springs of the Selçuk period, was dedicated by the daughter of Ramazan I. One of the palace secretaries of Alaaddin Keykubat, Kutlu Melek Hatun, on the other hand, was built and dedicated by her husband. The donated books to Darul Hüffaz, not only did they have foundations built, women who were members of the Sultanate also worked as trustees in some foundations. In addition, they established spiritual and physical ties with foundations that were unfinished, abandoned, or in need of repair, which were found by women before them. 18th century, the wife of Abbasid Khalif Harun Reşid, Zübeyde bin Hürrem, Mihrimah Safiye, and Turhan Sultan all had the waterways on Cafer Han's pilgrimage roads repaired during the Ottoman period. And conclusion, Anshia, who reigned in the Byzantine Empire, women of aristocratic origin, such as Juliana took Helena, the mother of Constantine I, as a role model, and Aleia by following the feminine virtues that came to life in Felicilla. They acted with the concern of creating a religious, charitable identity in front of the society. With the church, they built the holy relics they brought to the capital from distant places, and the structure they built for the relics of Mary, Jesus, and holy people. These aristocratic women not only responded to religious and social expectations, but also added great value of the female identity in Byzantium. In accordance with Ibn Khaldun's theory, there was no clear separation in the social strata in the first period of the establishment of Malk, the writings about the Sultan's wives also reflect the situation of other women in the society. Sultan Hatuns are not people who live in palaces without being disconnected from society. Like the rulers, they became active subjects of school, social, cultural, and religious life. Despite the widespread belief that women in the Seljuk state of Turkey were powerless due to cultural and customary practices that limited their physical access to public space and prevented them from expressing themselves, many women from the palace embarked on the development. Thank you.
Good day, everyone. I am Gil Yuzil Eluze, a master's student from MSU-IIT, or Mindanao State University Iligan Institute of Technology from the Philippines. So I am the author of the vibration analysis using finite element analysis, an evaluation of picotubular turbine blades fabricated in composite materials. So my co-author is also my advisor, Dr. Noel Hernandez. So the objectives of this study is, first, it utilizes FEM, or finite element method, to evaluate the composite material that was used to fabricate turbine blades. Second, we conducted CFD simulation to investigate the pressure fluctuation between the runners and the guide vanes. Third is utilize vibration simulation in ANSYS mechanical in analyzing random vibration. And lastly, we perform experimental investigation of pressure pulsation. The main aim of this study is to examine the effect of the random vibration to the composite blades fabricated in CFRP, or should I say carbon fiber reinforced material, and PLA, or polylactic acid. Another aim of this study is for marketability. It says here, easy energy harvesting for everyone. Next is cost reduction, which is in favor for the manufacturers. Third is energy harvesting in ultra-low head sources. It's because in our place, we have a lot of rivers that is considered ultra-low head source. And lastly, reduce plastic waste due to PLA and CFRP recycling. So these are the softwares used in this research. So we have ANSYS mechanical in FEA and random vibration, and SolidWorks flow simulation for CFD. These are the orthographic sketch and the cross-section of the design of my tubular turbine. Now, these are the instruments used to gather data, or to measure data from the pressure pulsation of the turbine blades. So we have the voltage voltage output of the voltage output pressure transducer. And then next is we have NI9201, a voltage data acquisition from National Instruments. And then the NI9201 will be connected to the CDAC of 9171. And these are only the available instruments in our university for pressure measurement. Now, we have our generated designs. So we have draft tube, runner blades, and then the guide vanes and the bulb casing. So in this case, we have the mesh geometry, and then it is generated in ANSYS mechanical. And then the meshing size of this mesh geometry is not lower than 100 millimeters. Now, these are the pressure transducer location. As you can see, we have red boxes here that signifies or represents the pressure transducer. So we have 4 pressure transducer, and then the 2 is specified here right after the runner, and then another pressure transducer is put between the guide vanes and then the runner blades. So the basis of this pressure transducer location experiment is because under the study of Moharta et al., it says here, or the claim of that study is that the pressure fluctuation in a turbine is usually occurring in between the guide vanes and the runner. So that is why we have here the pressure transducer placed between the runner and the guide vanes. And after that, the data will be imported to the vibration toolbox by Pam Irvine that is powered by MATLAB. Now, these are the boundary conditions. We have fine weather, which is 0.2 until it is increased up to 0.4. And then we have the CFD analysis computational domain where the limitation of the analysis is done. Now we have the materials for fabrication. So all of which, or all of these are 3D printed since it is modeled, no? From prototype to model. We use similitude theory. So from draft tube to guide vanes, bulb casing, it is 3D printed since it is very small because it's modeled. And then also for the runner and the turbine blades. Now, in this case, CFRP or carbon fiber reinforced plastic cloth is placed or coated in the runner blades in order to ensure the objectives or to make it a composite runner blades. And now we have the CFD results. In this case, this is the right side view of the simulation. So we have here, as you can see, from high pressure to lower pressure, we can see the pressure contour changes. So in this case, the high pressure is 180 kPa for case 1. And then it gradually decreasing until it go to the suction side. So as you can see here, the area where the runner or the turbine blades is placed, there are a lot of pressure colors. So that is why we can conclude that there are pressure fluctuations in this location that contributes for the random vibration situation in the runner blades. So these are the plane. No, we cut off a plane in the between the runner blades and the guide vane. So we have here, as you can see, the pressure concentration is near between the tip of the blades and then the draft tube. So we have here the maximum estimated pressure here is from 168 kPa to 176. And in the B, we have the that is the outlet of the runner blades. So in this case, the maximum will be, since it is in a low pressure side, so we have the estimated maximum pressure value, or maximum pressure value is 96 kPa. Now for the case 2, it also has the same situation for case 1, but the maximum pressure affecting the runner blades is increasing. So from 180 to it rises up from 216. Same also in the case 3 and then the case 4. And then the next is, since this is modeled due to unavailability of the commercialized dimension materials for fabrication, so now this is the CFD results of the model. Now, as you can see, the model here is experiencing also a different pressure contours. So we have from 106 kPa to estimated the maximum pressure will be 114 in this plane, no, since it is a cut-off plane from SolidWorks. And then we have here the velocity and pressure contour of the model. So as you can see, from a velocity of estimated from 0.5 to 0.7, and then passes through the runner, it increases speed. And now in this case, we have 1.76. And then the pressure contour also gradually decreases as the water flows from the inlet to the outlet. And now we extracted the values of maximum pressure, minimum and maximum pressure, and force due to liquid pressure values. That is affecting right in the blade. So we have, for case 1, the minimum pressure affecting the blade is 37 kPa. And for the maximum pressure is 128. And then in the force, maximum force is 0.3 kilonewton. So same also, as you can see, it increases as the volumetric flow rate increases. And for the model, we have 120 kPa max, and the minimum pressure is 94.6. And the force affecting due to liquid pressure in the blades is estimated around 1.483 Newton. Let's go now to the random vibration. So the data that is calculated in the flow simulation in the SolidWorks is imported to the ANSYS Mechanical. So the random vibration is calculated in a statistical matter using Gaussian method. So now we have the probability here. As you can see, the probability of the results is 99.73%. And now, looking into the directional deformation, so we have the maximum directional deformation is around 0.2394 or 914 millimeters, and it is located in the tip of the blade. Next is, we have the normal elastic strain in the z-axis. So as you can see, the location of the maximum strain is located here in the thinnest part of the blade. So that is why the concentration, we have 4 concentrations here, and then that is why the concentration here is located, since it is one of the thinnest part. No, and also it is 99.73% probability. And now for the stress, we have the maximum stress is located almost in the connection of the hub and the blade, but not in the location. So it is considered to be safe, since the maximum stress calculated in ANSYS Mechanical is 1.03 MPa. And in the study of Alzani et al., the maximum tensile strength of a PLA with 20% carbon fiber is 43 MPa. So we can conclude here that the blade fabricated in CFRP and PLA is reasonable and suitable for operational use. And now we will go to the acceleration. So these are the acceleration frequency response. So while the water flows, the flapping of the blades is almost in the 800 frequency. And then this 800 frequency is the natural frequency of the blade undergoing pressure pulsation. So, and then the next frequency recorded is 2.3 kilohertz. So this is the excitation frequency. And then as you can see, the excitation frequency is not equal or above the natural frequency. So therefore, it is safe, since resonance is not created. Same also for stress. deformation, and strain. And for now, the damping ratio is that from the common material steel, it is only 0.02. While the composite material combination of PLA and CF carbon fiber reinforced plastic, the damping coefficient calculated using this equation is that higher than the common material, which is steel, then the value is 0.08. Now, these are the geometrical parameters of the model and the prototype. Since due to incapacity to fabricate such large prototype, we use the similitude theory to scale down. And then we have the head over diameter ratio. So the HD ratio of the prototype is 6.62. And then the model of the HD ratio is 5.9 or almost 6. And this is the valid CFD validation test rig. So, and now we have the pressure transducer and identification of the test rig. So we put here the pressure transducer. So we have 4 pressure transducers. And this pressure transducer here, number 1, is where is put to in between the guide vanes and the runner. And then the pressure transducer number 2 is put after the runner. And now, these are the data gathered and interpreted in the pressure transducer 1 and 2. So as you can see, the natural frequency is 855, and then the value of the pressure is 175.62 kPa. And as you can see, here we have a lot of minimal excitation frequencies. So the 2 most valued excitation frequency is at 100,000 or 167 kilohertz. And then the value of this is 132.79. And the last is, or the second is 65 kilohertz. The value is 112 kPa. So as you can see, the resonant frequency is not equal or at most to the value of the natural frequency. Therefore, there is no resonance occurred in the material. No, there is no shaking that leads to failure. And then in the pressure transducer number 2, there is negligible resonant frequency. And now this is the picture of the pre-experimentation of the pressure pulsation. So we can see here that the turbine is working, and then the water, it signifies the evidence of the flowing water. Now, for the validation of the results, the simulation or the simulated data versus the experimental data has the maximum of 10.03%, while the acceleration is 2.66%, and then the natural frequency is 800 versus 855, so 6.65%. For the conclusion, composite material turbine blades designing picotubular valve-type turbine is possible. The frequency response analysis of the composite blades in pressure fluctuation validates the suitability of PLA reinforced with CFRP as an alternative material, since resonance of the material is not recorded in both experimental and simulation. And for the damping ratio, it signifies that since the composite material has a higher damping ratio, therefore it has the power or amount of power to dissipate the energy which is caused by vibration. And for the recommendation, conducting an FSI, fluid structure interaction analysis, to evaluate the cavitation-induced vibration, and Second is study the effects of cavitation on the fabricated composite blades, and perform a prototype experimentation to prove that the claim that the higher HD ratio will experience less pressure pulsation. So that would be all.
So this is Dr. Ammar Dawal. I am Associate Professor, Chairperson of Telecommunication Engineering Department at Ahli University. I'm going to present this research or this project, Smart Traffic Sign to Control Highway Speed Limit. So as an introduction, there is a high impact of speed on road accidents, and there's a clear relationship between the speed and the severity of the accidents. However, some drivers didn't consider the weather during their driving, so they can drive in high speed, although the weather is not suitable for this speeds. And as per statistics, we found that there is more than 5 million vehicles crashes per year, with average of 1.2 million vehicles crashes involved due to the hazard of the weather. And 20%, which forming 21%, resulting in more than 5.5 thousand deaths per year. All this is due to the bad weather and didn't consider the weather while driving. So the idea here is we're going to develop an application or the system that monitors the weather, and on time or real time will change the speed limit in the street. So if the weather is wet, then the speed limit will be reduced, and if the weather is fine, then the speed limit will be the maximum possible. For that, we prepared this system that consists of a camera that will going to capture street images, and then through imaging processes, image processing program, where we used deep learning algorithm, which is convolution neural network. And this algorithm, with its available libraries, it consists of conv2D layer that is used to convolving the input in two-dimensional space, with 32 filters applied to each layer and filter kernel size of 3. Adaptation function of ReLU is used to add nonlinearity to the output. We use dataset consisting of 20,000 images for training the model, and we use the Arduino integration, in which the Arduino will be used as a microcontroller that will accept the images. First, we have the camera that will capture the images, pass it through the Arduino. It will be passed to the algorithm, deep learning. And the result, which at the algorithm, it will decide whether the image has a wet rains, means the weather is wet, so it has the raindrops, so it will recognize raindrops. In case of it has raindrops, in all cases, it will pass the result to the LCD display, which will represent the output. So if the algorithm detected raindrops in the image, that means the weather is rainy. So it will produce a message that has a low speed limit. For example, could be 80 kilometers per hour. And if the output produces that the weather is fine, there is no raindrops are detected from the image, that means the weather is fine. So it will display the normal speed limit, for example, 120 kilometers per hour, 120 kilometers. So this is the flow chart of the algorithm. So we start with the image, we start with the input imaging. So we load the image, pass it to the algorithm, and the algorithm will be trained. So we're building the deep learning algorithm, and it will be trained on the images, and we test the results. If the accuracy is accepted, then we produce the output, and accordingly it will make prediction. That means either it is wet or not wet, and the output is again sent to the Arduino, and Arduino will send it to the LCD to display the proper speed limit for the traffic. The results we obtained that after training and implementing the system, we got an accuracy of 96.81. Means here the target is either to detect raindrops in the image or there is no raindrops. Raindrops means the weather is wet, so we need to produce a message with low speed, and otherwise it will be the message with the high speed or maximum possible speed for the traffic. The precision we got is 97.3, recall was 97.36 also for the test data sets. In fact, this project has many benefits and applications in real world. So the advantage of this project, it is scalable, so it can be easily replicated in various locations, allowing for scalability and wide-speed implementation. Another advantage that is cost-effective implementation with a very small components and cheap components like simple camera, web camera we can use also with Arduino microcontroller, in addition to available libraries on Google that are used for classification or for prediction for the results. Also to enhance the traffic management agencies, long-term cost saving by reducing accidents, because as we mentioned that many accidents are due to the not fulfilling the speed limit while on the wet street. So this will provide a proper speed limit during wet weather. So it will reduce accidents and also potentially will save lives. As we mentioned, as we saw earlier, that 5.5 thousand deaths per year due to the bad weather accidents. In addition, it enhances road safety. It has real-time monitoring for the street, and finally improves efficiency of the traffic agents so they can control the traffic properly. Finally, for the future plan, of course, this system, this is just an idea that can be expanded for different weathers, for example. So we can add more sensors for moisture and, for example, for fog and so on. We can also use advanced processing techniques to detect other types of bad weather, such as dust or fog, like in our area. Also, it can be integrated with the navigation system. We can collaborate with the weather forecast agencies to provide, maybe make our system more accurate in predicting the proper weather and provide a proper speed limit. Also, it can be expanded to urban areas. By that, I conclude my presentation, and thank you for listening.
Thank you everyone for your kind patience. I've shared my email address. You can mail me. Anything is there. We can, we can plan what best can be done. Thank you.